All right, so in yesterday's notes, we talked about the two special right triangles. The first being the 45-45-90 triangle, which is your isosceles right triangle. And the relationship between the sides on those triangles would be A, and A root 2. And then the 30-60-90 triangle, in which opposite the 30 is your A, opposite the 60 is the A root 3, and opposite the 90 is the 2A. And then we were given one of the three side lengths, and you had to work to find the others, or the couple of applications, like the square with the diagonal, which is really a 45-45-90, or two 45-45-90 triangles, and then it was either, and then we did an equilateral triangle with an altitude, which breaks into two 30-60-90 triangles. So those kinds of scenarios will always happen. So on the warm-up, this picture doesn't change page by page, but what it's asking for does. So this one says find the value of A given B is 10 root 2. So if this is my 10 root 2, I'm obviously using the triangle on the left. And don't confuse like the A's and the B's with the A and the B on this one. This time the A does align, like this is our A side and this is our A side and this would be our A root 2. But sometimes they reuse the variables, so just be really careful. So if 10 root 2 equals A root 2, then I would just divide both sides by root 2, and I get A as 10, which means both sides would be 10.
I feel like the IDs are irritating my neck.
Put it around your collar. Questions on that one? Nope. 2 says find the value of B if A is 19. So now it's giving you the A side. Again, this would be your A root 2. So if this is 19, then B is 19 root 2. You're just going to plug the 19 in the place of the A. 3 is now using the other triangle. So now we're on to the 30-60-90 triangle. The opposite, the 30, which would be at the top, would be your A. Opposite the 60 on the right would be A root 3. And then opposite the 90, which is the E here, would be 2A. And this time it gives you C is 4. So it's giving you the A side, which means that D would be 4 root 3. And E would be 2 times 4 or 8.
Okay, so like when you do the 4 root 3, you like, let's say it's a number you could put back into the square root and then square root it.
You're never plugging a number into the underneath the square root for these though. Yeah, because the root's part of your value. Unless there was a root and you multiplied that root by the root, then it would change it. All right, 4, again, we're using the 30-60-90 triangle. So opposite the 30 is your A. Opposite the 60 is A root 3. Opposite the 90 is 2A. And this time they give you the 2A side. So if 2A equals 50 square root 3.
You're going to have to divide by 2.
Divide by 2. And A is 25 square root 3. So that's the value that I would set equal to C. So C is 25 square root 3. That one's done. D is 25 square root 3 times the square root of 3. So this is what I was talking about. When you have a radical multiplied by another radical, you can multiply them. And specifically, if it's the same, if square root 3 times square root 3 becomes what?
Square root 9.
Which would be 3, right? So you could shortcut it, just get what's underneath, and then that's 75. So D is 75, and C is 25 square root 3. Questions on that one?
Wait, so 2A was, what was 2A?
50 root 3. So we divided by 2. All right, and then number 5 has a couple of different things happening inside it. This is actually a trapezoid because there's one pair of parallel sides. But on the left and the right, they've made these little triangles. On the left, it's a 45-45-90 triangle. On the right, it's a 30-60-90. And the only value given to you is there on the left. So if I start with that triangle, which is where we'll start because it's the only place we can start, this would be my A, this would be my A, this would be my A root 2. So if 6 equals A root 2, I would divide both sides by root 2. A would equal 6 over root 2. We did this one yesterday twice, I think, actually. So A would equal 6 root 2 over 2, which becomes 3 root 2. So that's my X, 3 root 2. And it would be the bottom side, but I don't need it. Then, because this is those sides are parallel, and then these sides would be parallel because of those 90-degree angles, right? Those would be corresponding, or two lines perpendicular to the same line would be parallel. This is a parallelogram, and in a parallelogram, opposite sides are congruent. So if this side is 3 root 2, then this side is also 3 root 2. And now I'm dealing with the triangle on the right, which is a 30, 60, 90 triangle.
Are there only going to be the two triangles? Like on the test, like 45, 45, 90, and 30, 60, 90?
For special ones, yes. On the test, we're going to get into more stuff. But for the ones that you do without your calculator, you can only do 30, 60, 90, or 45, 45, 90. Or the Pythagorean theorem if you have two sides. But if you only have one side, it has to be one of those. So then opposite the 30 is your A. Opposite the 60, which would have been at the top, is your A root 3. And opposite the 90 is your 2A. So if 3 root 2 equals A, then my Y is going to be 3 root 2 times root 3, which is 3 root 6. Square roots don't cancel out that time because they're not the same number underneath, but you can multiply out 2 square roots to just multiply what's underneath. And then Z is going to be 2 times 3 root 2, which is 6 root 2. So X was 3 root 2. What?
We already have A.
Yeah, that's it. That was the last one we needed to get. X is 3 root 2, Y is 3 root 6, and Z is 6 root 2. Yeah. Sure. Sure. Yeah, for a 45, 45, 90, you can always use the Pythagorean theorem. I think depending on what you're given, it might be faster to use the 45, 45, or the A root 2, but you can always use it. Yep.
Will there ever be a time where it's faster with the Pythagorean theorem?
Faster with the Pythagorean theorem? I mean, if you're not good at the dividing by the square roots, sure. You'd still end up with roots in your answer, but they wouldn't come until the end.
It's basically like a better way to just do it like you taught us.
It's up to you. Yeah. Everybody's brain works a little different. You get to choose. Okay. So this was the question that came up from the homework. I think this is 14. The drawbridge one. It said each half of the drawbridge is about 284 feet long. And it made the little triangle inside. It says, how high does the drawbridge rise when X is 30? So if X is 30 degrees, then this is my A, this is my A root 3, and this is my 2A. So if 284 equals 2A, then A would be 142. And that's how high that side would raise. So how high it would raise would be from where it's flat to the top, which would be 142. That's the first question. The second one says, how high does the drawbridge rise when X is 45? So I would then change these side lengths because this would be 45. This would be A, and this would be A root 2. So if 284 equals A root 2, I would divide both sides by root 2. A would equal 284 over root 2, which would get rationalized to 284 root 2 over 2, or 142 root 2. Now on tomorrow's quiz, you will leave it like that. Okay, you won't have the calculator to actually multiply it out. It would say keep it exact, and you will leave it as 142 root 2. But on, and I actually think nothing on tonight's homework has you round. It's all kept exact just like that. On this specific question, which would be, I would say, something almost like a standardized test, it will just ask you to round. So you just have to multiply that out. You're going to multiply the 142 times the square root of 2.
First one is easy. I got 147 because obviously you just had to divide by 2. But then the second one was harder.
This bumps that up. Did I say tomorrow?
Yeah.
No, sorry. Quiz is Thursday. Tomorrow we're going to review. Yeah.
You have these good.
How do you get, or did you already do it?
Solve for A. For the second one, yeah, I already did it. The 284 that time is your A root 2. So you have to divide both sides by root 2. And then rationalize. Technically, so like on the quiz, obviously you'd be looking for an answer like that. So you'd have to go through the rationalization process. If it was just a standardized question, or if it told you to round, you could do that from here. I could do 284 divided by the square root of 2, and you'd get the same answer. So if it allowed you to use your rounded answer, you could do it from the beginning. But on the quiz, you're going to, and test, probably a question like this will be asked to keep it exact. The test, you'll have your calculator, but you'll have to make sure you keep your answer exact at the end. So it would still be that 142 root 2. When Sebastian comes back. The last question says, how high does a drawbridge raise when x is 60? So now if I were to switch that x to be 60, the relationship of my sides change. Opposite the 60 would be my a root 3. Opposite the 30, which would be at the top, would be the a. And the 284 would be the 2a. So I would divide both sides by 2. And that's 142. So if a is 142, that's here at the bottom. It wants this side, which would be 142 square root 3. And again, on a test or quiz, you would leave it exact. But on this homework, it wanted you to round to the nearest hundredth. So 142 times the square root of 3 ended up being 245.951, which means the last bit drops off, and it would be 245.95. You are going to have to start paying attention to instructions like round to the nearest 10th, round to the nearest hundredth. Obviously, that, especially when we get into the next section, that's important. 10th is 1 decimal place. 100th is 2. You need to know that. I won't answer that kind of question on a quiz or a test. So you need to make sure you know that. Any questions on the homework before we move into today's notes? Okay. Today we continue talking about just right triangles. Really, the rest of this chapter is just right triangles. But today we talk about similar right triangles. So in similar right triangles, just like any similar polygon, the angles are going to be the same. The sides would be proportional. But there are special relationships within triangles that cause these to form. And this is the first one. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So if the altitude is drawn to the hypotenuse of a right triangle. So what that means is two things. First is the big triangle has to be a right triangle. So in order for this theorem to work, the big triangle has to be a right triangle. You'll see the little right angle at the top there. This can be turned in any direction, but it has to be a right triangle. And then an altitude has to be formed. And by definition, an altitude is a segment that hits the opposite side at the right angle. The altitude has to be drawn to the hypotenuse of the big triangle. So you need two right angles happening in your triangle. One at where the legs meet in the big triangle, obviously, and then from that angle needs to come the altitude. All right, so then we're going to, when these kinds of questions on the homework and on the quiz, it's going to ask you to make a similarity statement. So I'm going to start with the big triangle. I'm going to call it whatever name I choose, but if I call it A, B, C, the order of how I name the other ones is important. It has to go in the same pattern that I just created from that big triangle. So if I look at the big triangle, I've got two legs. Obviously, one is shorter than the other, and I've got a hypotenuse. And the order of the letters I chose was the longer leg into the hypotenuse, which means I have to state the other two the same order. So let's say I focus on the one on the right. The longer leg is the one on the bottom, and the hypotenuse is A, B. So when I rewrite the order of those letters, it has to be D, B, A. Any other order is wrong. It has to go in the same pattern as the one you established from the first one. Yep. So the big one, like even if you wanted to give it value, you could, but The big one, I went A, then B, then C, right? Like those are the letters I used. A, B is the longer of the two legs because the other one is AC. Like that's my middle length side, if you want to look at it that way. And then BC is the hypotenuse of the longest side. So then when I go look at my smaller triangle, or the triangle on the right, I have to go in the same order. I have to pick the middle side that leads into the hypotenuse. So middle length side of that triangle would be DB, and then it leads into the hypotenuse, which would be BA. Does that make sense? So we're going to do the same thing with the other triangle. Now I'm going to look at the one on the left. The longer leg is which one? The longer leg is AD, right? The hypotenuse is AC. But it has to go longer leg into hypotenuse, which means I have to go D, then A, then C. If you had rotated the first one, then the other ones rotate. But if you choose A, B, C for that first one, and you have to, again, pay attention to the order of the letters, if you put them in any other order, it is wrong. There's 2 questions like that in the homework, and there will be a question like that on your quiz. I feel like they tend to start the big one in alphabetical order, not always, but they tend to start the big one in alphabetical order and then go from there. All right, you do this one. Identify the similar triangles. So give me the statement of similarity of all 3 triangles. Use alphabetical order to start the first one. Let's make it easy so everybody starts the same way. All right, so if I start by naming the big triangle, triangle RST, just so we keep it in alphabetical order, the order of those sides are actually hypotenuse into smaller leg. So when I go to name, I'm going to start with the one on the left. When I start to name that one, what should the order of the letters be? What would be the hypotenuse there? RT, and we want to go into the shorter leg, which is TU. Good. So it would be triangle RTU. The hypotenuse of the blue triangle, right, is opposite the right angle here, which would be that one. Then you want to look at the one on the right, this smaller triangle here. What's the hypotenuse of that triangle? TS or ST, and then the shorter side is SU or US. So I need to go T to S to U. And again, order of the letters is important. Questions on that one? Okay. Geometric mean is something we're going to use for the last 2 theorems. And the geometric mean sounds scary. It is just the square root of the product of 2 numbers. So if I have 2 numbers, I square root the product, and product means what? When you multiply. So you're going to take those 2 numbers, you're going to multiply them, and you're going to square root them. The best thing I could tell you here, though, is don't actually multiply the 2 numbers out. So if I'm trying to find the geometric mean of 2 and 12, instead of square rooting 24 and then breaking it back down into 2 and 12 and 2 and 6 and 2 and 3, because I have to simplify it, I literally keep it as the square root of 2 times 12 and then break it down from there. So it saves you a couple of steps sometimes. And the bigger the numbers, obviously, the bigger the product that you then have to break back down. So if I did have this one, 2 2's would go to the outside, and then there'd be 1 2 and 1 3 left underneath. So this would be 2 square root 6. So geometric mean means square root the product of the 2 numbers. This is where it comes from. Like the first number over x would equal x over the second number, and then you'd cross multiply and you'd square root. You just save yourself the setup steps. Yeah, like if you put it, so this says find the geometric mean of the given numbers. So for A, it's 4 and 20. I would square root 4 times 20. And again, I wouldn't bother multiplying them out because I would just end up having to break it down again. 4 would be 2 and 2. 20 is 2 and 10, which is 2 and 5. There are 2 2s, so a 2's going to the outside. There's another pair of 2s, so another 2's going to the outside, and the 5 is left underneath. So this becomes 4 square root 5. And you'll keep all these answers exact. Go to B. Square root of 9 times 25. They're both perfect squares, right? So 9 comes to the outside as 3, and 25 comes to the outside as 5. And I get 15. So this is one of those scenarios where if I had actually multiplied out underneath, I would have gotten a perfect square. It's 225. You might not know it off the top of your head, but that's the square root. That's the square of 15. Questions on those? All right, so this is the first theorem that uses that geometric mean. It's 9-7 just because it's the 7th theorem mentioned in your chapter 9. Okay, so this one says in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. That's the first part. So altitude to the hypotenuse of the big triangle divides it into 2 segments. We literally call them segment 1 and segment 2. And it doesn't matter which one goes where. The length of the altitude is the geometric mean of the lengths of those 2 segments. So if I took those 2 segments and I multiplied them together and I square rooted them, that's what the geometric mean means, I would get the length of the altitude. Instead of using all of those words, we set up this little proportion. So there's going to be 2 proportions you're going to want memorized by the end of today. And this is the first one. Segment 1 over altitude equals altitude over segment 2. And then we cross multiply and solve. So sometimes you're going to get both segments and you're looking for the altitude length. Sometimes you're going to get one of the segments and the altitude and you're looking for the other segment length. You will eventually be able to cross multiply and either square root or cross multiply and divide to solve this proportion. But segment 1 over altitude equals altitude over segment 2. The second theorem that we're going to set up a proportion for is the geometric mean leg theorem. And it says in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. Exactly the same statement as the last one. This time we're talking about the legs of the right triangle though, so the outside sides. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that's adjacent to that leg. Oh, this is C. This got cut off. So if I look at the big triangle, this right angle is also missing. That would be there, okay? Because the big triangle has to be a right triangle. And then I can say the hypotenuse of the big triangle, which would be side C, this whole thing, would equal a leg, and I can pick either leg. So let's say I'm trying to find X or I have X and I'm using it. That's one of the legs. Would equal that same leg, so the X repeats, over the segment of the hypotenuse adjacent to that leg. So we said these 2 segments are formed when the altitude hits. And for this scenario, I want to pick this segment that is next to, because that's what adjacent means, the X. And that's why you would choose A. So C over X would equal X over A. Hypotenuse over leg equals leg over segment of hypotenuse adjacent to the leg, which you will see as segment of hypotenuse adjacent to leg. I will never write that whole thing all the way out again. Yeah, I know. You call it what you want. But the segment of hypotenuse adjacent to the leg is, we just use the acronym.
Wait, but we're finding the same answers that we did in 9.1 or 9.2.
No.
Mine's the same right triangles.
They are right triangles, but if you look at the one that's here, right, you'll be given the big side, not the altitude, and that's for the first one. So you can't use Pythagorean theorem because you don't know the segments and the sides. You'd need to know 2 of the 3, which you don't have. You're given different, you'll see it when you see a picture, you're given different information than the Pythagorean theorem. And then you can also use this to find y. So if I wanted to find y, or if I had y and I was using that to find the segment, then I would use this side. So C is still the hypotenuse of the whole triangle. It would equal y, or C over y, sorry, would equal y over now the segment of the hypotenuse adjacent to y, which is B. So you can use this for two different setups on every triangle. One with the segment 1 and that leg, and one with the segment 2 and that leg.
What was the first theorem?
What?
What was the first theorem?
All right, so this example puts them both together. And depending on the information you're given, it will depend on which of those theorems you pick. So if the information given involves the altitude, you're going to pick the first one. If the information given involves the leg, you're going to pick the second one. So I'm going to label these separate. I'm actually going to duplicate this. For A, it says if JR, so JR is this segment here, is 16, and EJ, which is this segment here, is 9, find, the first one is HJ, the second one is RE, the third one is RH, no, sorry, second one is RE. I wrote it on the wrong one. RE, which is this whole thing. RH could be a Y, and HE could be a Z. Or you could use the letters. It doesn't matter. We know we want to solve those one at a time. So let's say I want to start with X. What information is given to you? What are those things called? Is that a hypotenuse, a segment, or a leg, or an altitude? EJ would be a what? EJ is one of the segments. JR is a segment, right? So which of the, and then X is what I'm looking for, and X is what? The altitude. So which of those two theorems do you think you're going to use?
First one
over the altitude
equals altitude.
Good.
Segment 2.
Segment 1 over altitude equals altitude over segment 2. And segment 1, segment 2, like I said, the order doesn't matter. One's 9, one's 16. It doesn't matter which one you use to which. But segment 1 could be 9. The altitude is the X that I don't know. The altitude would repeat as X, and segment 2 is 16. And I cross multiply, and I get X squared equals, and I'm not even going to multiply it out, 9 times 16, because my next step is to square root it. And the square root of 9 comes out as 3, and the square root of 16 comes out as 4. So X equals 12. Now I know the altitude. So now I have choices. I can either do the Pythagorean theorem for both of those smaller triangles, or I can use the other proportion. Since we're practicing the proportion, I'm going to do the second method. But once you get that altitude, you could also use the Pythagorean theorem for both of those. So let's say I want to solve for y this time. Y is what? Segment, hypotenuse, altitude, leg of the big triangle. It is what? A leg. So I'm going to use the second proportion. Hypotenuse over leg equals leg over segment of hypotenuse adjacent to the leg. So what's the hypotenuse of the big triangle? Because that's the hypotenuse we're using.
What?
Nope, of the big triangle. 25, which is actually one of the questions it asked for, right? RE is 25. So 25 over the leg we're looking for this time, we're solving for y. So we're going to put the y equals the y repeats. And I want the segment of the hypotenuse adjacent to that leg, which would be 16. Good. Cross multiply, y squared equals 25 times 16, and y equals the square root of 25 times 16, which becomes 5 times 4, or 20. And that y was on HR, or RH, so that's 20. We found HJ already, that was 12.
Wait, so how can you know, like, oh, never mind.
Okay. So now I have three choices to find z. I can either use the Pythagorean theorem for the small triangle on the left, I can use the Pythagorean theorem on the big triangle, or I can set it up again, and that's what we're going to do just to practice it. I can set it up again with z being the leg I'm using. So hypotenuse is still 25. The leg we're trying to find is z equals z over the segment of the hypotenuse adjacent to z, which is? Good. And I'd get z squared equals 9 times 25. Z would equal the square root of 9 times 25. 3 times 5, which is, well, the square root of 225, which would be 15.
Yep.
And those are both triples. The big triangle is 15, 20, 25. That's a triple. The triangle on the right is 12, 16, 20. That's a triple. And on the left, 9, 12, 15 is also triple because they're all whole numbers.
Are you going to be nice to us and always make the numbers like square root?
I think I'm nice to you all the time, but I'm not. I don't think that means I make them all square roots. Well, I mean, payback.
Payback for what?
All right, go to the second one. So again, I just duplicated so I could write all over it again and not lose all that. So for B, which is what the second one should say, JR is 4. JH is 2. And the first thing it wants you to find is EJ. So let's go one at a time here. What information do I have? What kind of segments and, yeah, what kind of segments are those?
Well, now we know that HJ is 2 and JR is 4.
Okay, I have the altitude and the segments of the hypotenuse, right? This is a right angle. So I'm going to use that first one. Segment 1 over altitude equals altitude over segment 2. So segment 1 could be X or 4. It doesn't matter.
Wait, it doesn't matter which one segment 1 is?
Nope. Over altitude is 2. 2 repeats. And segment 2 is 4. So this time, there's not 2 x's. When I have the altitude, I'm just going to cross multiply. I get 4x equals 4. And then divide. And x is 1. So HJ is 1.
I thought AJ was 2.
No, sorry. What I just find. Oh, I wrote the wrong. Oh, no, I'm doing the second one.
So,
EJ is 1. Sorry. Now you're back to having choices. I can use the Pythagorean theorem on the right triangle. I can use the Pythagorean theorem on the left triangle to find those missing, but we're going to practice the legs again. So RE is next.
so that's 5.
And that is 1 up. That's what? What kind of segment?
The hypotenuse.
It's the hypotenuse of the small triangle, but when we say hypotenuse, we don't mean small triangle, right? Of the big triangle, it's a leg. Good. So it's hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. The hypotenuse is of the big triangle.
So it's 5.
Good. Which is actually one of the questions, right? RE is 5. The leg we're looking for, we called y, would equal y over the segment of the hypotenuse adjacent to that leg, which is 1. So y squared equals 5. Y equals the square root of 5. And that's HE. And then the last thing we're looking for is RH. We could use the Pythagorean theorem for the small triangle on the right. We could use the Pythagorean theorem for the big triangles. Or what we're going to do is practice this again. Hypotenuse of the big triangle is still 5. The leg is now Z equals the leg, which is Z, over the segment of the hypotenuse adjacent to that leg, which is 4. Good. So Z squared equals 5 times 4. You can multiply it out, but you're just going to end up square rooting it and breaking it down again. And this becomes 2 square root 5.
So why'd you do like 0? Z equals 5 times 4. Z squared equals 5 times 4. When you just do Z squared equals 20.
Because you're going to break the 20 down again anyways. Right? You're always going to end up breaking that square root down anyways. So you might as well leave the product separated. You could do it 20 if you want, but then you're going to have to break it down anyways. Mars.
I just know which one's adjacent again.
Adjacent would be next to. So if I'm solving for this leg, then I need that segment. If I'm solving for this leg, then I need that segment.
Okay.
Questions? So the homework for tonight, like all but 2 questions, are ones that you have to actually set up and work out. The 2 questions that don't require work are the ones that ask for the similarity statement. But the rest of them you need to show your work for. Some of them just are geometric mean, and then some of them are the actual diagrams where you have to set it up. So all of those require work.